Trigonometry, section 6.2, trigonometric equations, part 1. First, there are really three types of equations. There are conditional equations. There are contradictions. And there are identities. Conditional equations are sometimes true. Contradictions are never true. I guess we should put true here. And identities are always true. Now we've done the identities in chapter 5. Contradictions are when we come up with something like 0 equals 1, and that will be covered here. Now we're going to try one that you can't factor. If you try to factor this, you won't be able to find the factors. So what do? The quadratic formula. So A is a 2, B is also a 2, and C is a -1. But now we're not solving for x, we're solving for cosine theta, which is the opposite of b, plus or minus the square root of b squared, which is 4, minus 4 times a negative, so it'll make it positive, times a times c, so it's 8. All over 2 times a, which is 4. So this is a -2 plus and minus the square root of 12. Over 4. So the calculator is the best way to use this also. So I'm going to store this again. It's a little easier when you store it. Let's put parentheses first for your numerator. Parenthesis and -2 plus square root 12, close your numerator and divide by 4. I'm going to store that into alpha A. Now I'm going to take the same thing, and you can use second enter to pull back previous commands. Do it twice so that you can bring back the expression for your quadratic formula and change that plus to a minus. And now you get a -1.366. So I'm going to store that into alpha B. So an A is the positive 0.366, etc. And B is the -1.366. Okay, so how do I find those? Well, remember, that's what the cosine is. So if I need theta, I want the inverse cosine of that 0.366, or the inverse cosine of -1.366. And because we're talking about thetas, they want theta in this 0 degrees to 360 degrees. Well, let's see when we do. Inverse cosine of A, which is the 366. Oops. Inverse cosine of A. Close the parentheses. 68. Make sure mode. Yes, degree mode. 68.53 degrees. We'll just cut it off at that. With the other one, inverse cosine of alpha B, close the parentheses. It says value entered is not allowed in this function. Why is that? Let's go to quit. What was B again? A -1.366. Well, remember, the cosine can be as small as a -1 or as large as a +1. But there isn't any cosine that's a -1.366. So that's an extraneous solution. Only these two. And remember, just think of this as a reference angle. Where is the cosine positive? First and fourth again. So 68.53 is good. And if I want to go all the way around, you take 360 minus the 68.53. $291.47. So there's one answer. This is 5.3. There's the other answer. But this was an extraneous solution, so we didn't need that one. Trigonometry, section 6.2, part 3. Just want to remind you of the 3 rules to follow when solving trig equation problems. If given an inverse, like sine inverse, cosine inverse, tangent inverse, etc., then use the restricted domains and ranges. That's part of the problem. If given an interval, theta from 0 degrees to 360 degrees, x from 0 to 2 pi, things like that, then use the interval. And if given find all, then use number 2 above and add plus 2 pi n plus 360 and 360 degrees n, where n is an element of the integers. As an example of that, let's do a problem. Suppose you have the tangent of x times the tangent of x minus 2 equals 3. Now, it's so tempted at this point to say, ooh, I can just take these because it's factored already. But that's only when you've got 0 on the other side. So, in this case, they want to find it for all x. Excuse me. So you've got to distribute this. Tangent squared x minus 2 tangent x, and bring that 3 over, subtract 3 from both sides, so you can have it equal to 0. And then see if you can factor. In this case, we can. So tangent x times tangent x is tangent squared. 3 times 1 is the only way to get 3. We need a negative 2, so it's negative 3, positive 1 to give us the negative 3. So the tangent of x minus 3 is 0, or the tangent of x plus 1 is 0. This means the tangent of x equals 3, and this is the tangent of x equals negative 1. Now 3 is not special, but negative 1 is. So when is the tangent equal to a negative 1? Well, first of all, when is the tangent negative? Second, fourth quadrant. Then you bring out, if you know it's special, and say, when is the tangent equal to 1? Well, that's when we got the square root of 2 over 2, square root of 2 over 2. So now, do they want this in radians? I guess they do want this in radians. It says it in the problem, but I didn't write it down. So it's pi over 4. But remember, that's just a reference angle. Because pi over 4 is right there. Which one is this? Well, that's 1, 2, 3 pi over 4. 4 is pi. 5, 6, 7 pi over 4 is 1 pi over 4 less than 2 pi. So we've got those two that are special. Now, the other one, we need to figure out, first of all, the tangent is positive in the first and the third quadrants. We got to figure out that angle. Need our trusty calculator. Clear out that stuff. So we need the inverse tangent of 3. Make sure we're in the correct mode. Degree mode? No, we want to be in radian mode. Second quit. So make sure you're in the correct mode. Remember, this is x equals inverse tangent of 3. And when you press enter, you'll get x is 1.249. That's radians, that's not degrees. Now 1.249, if you remember your numbers a little bit, this is pi over 2, which is like half of a pi, right? So it's like 1.74. So this is the 1.249. That one you didn't have to worry about. Pi is 3.14. We'll say 141. And then we go another 1.249 from that. So 3.141 is 10, 8, 9, 3, 4.390. That's this one right here. So our four answers: 1.249, 4.390, 3 pi over 4, and 7 pi over 4. 2 of them exact, and 2 of them just approximations, because it's got the pi in there someplace, but it's in the 1.249 and the other. So that's what you need for section 6.2 and solving problems like that. We're going to go on to 6.3 also. So section 6.3 is really trig equations part 2. And what this deals with is not single angles like x, but maybe multiple angles, 2x, 3x, x over 2. So we might need some of our identities for those. For example, suppose you have the simple one, sine 3x equals a negative 1. If there is only one trig function, then think of that 3x as just your angle, 3x. And figure out then where the sine is equal to a negative 1. So you're going to think of sine being a negative 1 is special. Where's the sine equal to 1? Well, that's the square root of 2 over 2, right? I'm sorry, square root of 4, which is 2 over 2. So it's at pi over 2. Just think of that as a reference angle. So the sine is 1 at pi over 2. But remember, we want the sine to be a negative 1. So it's really down here at 3 pi over 2. But that's the only place. Remember, I guess 3x is going to be in the interval from, x we want from the interval from 0 to 2 pi. 3x, we're going to find it and show you how to use the 3 in there. But if we want x in this interval to 0 to 2 pi, going around the circle once isn't going to make it. This 3 tells you how many times you go around the circle. So the first time around the circle, It's 3 pi over 2. But it'll hit that because we're going to go 3 times around. Another 2 pi added onto that. So it'll be at 3 pi over 2. And then it'll be at 2 pi plus 3 pi over 2. That's the second time around the circle. First time around, second time around. And the third time around the circle is really 4 pi plus the 3 pi over 2. Well, let's figure all these out with just pi over 2's, right? So it's 3 pi over 2. It is, how many pi over 2's is 2 pi? Well, that's 4, right? 4, 5, 6, 7. 7 pi over 2. And 4, how many 2's? That's 8 pi over 2, right? So 8, 9, 10, 11 pi over 2's. But that is what 3x is, right? One of these three. But we don't want 3x, we just want x. And this is outside of 1 time around the circle. But to get that back to 1 time around the circle, you take it back to x. Divide by 3 or multiply by 1/3. So x is going to equal 3 pi over 2 times 1/3, 7 pi over 2 times 1/3, and 11 pi over 2 times 1/3, or 3 pi over 6, 7 pi over 6, 11 pi over 6. The only one that reduces nice is this. That's pi over 2. Interesting. 7 pi over 6 and 11 pi over 6. It's 11. Now remember, the reason this works is because you're not finding the sign of x, you're finding the sign of 3x. So when you plug in pi over 2 for x, you're really getting 3 pi over 2. When you plug in 7 pi over 6 for x, you're really getting 7 pi over 2, because when you multiply by 3. And you plug in 11 pi over 6, you're really giving 11 pi over 2 because you multiply by 3. So these are the three values. So how do you solve these? If you just have one trig function, sine 3x, whatever, then you figure it out for that angle, 3x, 5x, 2x, 1/2 x, whatever it is, and then sort of solve these lists. Here you divide by 3, multiply by 1/3 is usually easier.